Good morning, good afternoon, good evening, everyone. Welcome to the Partnership for Lead-Free Future webinar to launch the latest tool in its toolkit to end childhood lead poisoning. It's called the Strategies to Encourage the Environmentally Sound Recycling of Used Lead-Acid Batteries, or ULABs, as we call them. My name is Angela Bandemer. I'm the Senior Technical Advisor at the Partnership for Lead-Free Future, and I will be moderating this webinar today. This tool is available on the PLF website and is intended to support policymakers and civil society organizations to address lead exposure caused by ULAB recycling, and we'll put the link in the chat. Some logistics for the webinar. The webinar will last 1.5 hours and is being recorded. We will provide the recording and the slides on our website. Please feel free to ask questions in the Q&A or in the chat throughout the webinar as they occur to you. Speakers and others monitoring chat will answer them. You will also have a chance to ask questions during a panel and Q&A session at the end of the presentations. And as we go through, feel free to introduce yourselves in chat with your name, country, and organization so that we get to know who's joining us here today. Next slide, please. So I'd like to begin with introducing our speakers. We've got Dr. Chris Canale, from a senior research scientist from Pure Earth. We've got Fred Ajayi, who's from the Öko Institut and is a researcher. Tom Daniels is the co-executive director for the Lead Acid Battery Recycling Initiative, LABRI, and Dr. Atiemo Sampson, who is the executive chairman of the Mountains Research Institute. Next slide, please. This is the agenda for the webinar today. We will start with presenting information on the health and environmental impacts of used lead-acid battery recycling. Then we'll go through the technical and then policy options for interventions for ULABs. And we'll round it off with a case study from Ghana. Then we will leave time at the end for a panel discussion and Q&A, and then close with key takeaways and next steps. So again, welcome to everyone. Thank you to the panelists, and I'm going to start with the first. Please, next slide, please. So we're going to start with Dr. Chris Canale, who will talk about the environmental health impact of lead releases from ULAB recycling and take it away. Thank you.
Hi, everyone. Next slide, please. Thanks, Angela. I'm Dr. Chris Canale. I'm a senior research scientist at Pure Earth, and a core focus of my work is investigating the lead exposure pathways and health burden from lead-acid battery recycling. Next slide, please. So why do we care so much about lead-acid batteries? Well, approximately 86% of the global lead supply is used to produce lead-acid batteries, representing the vast majority of the global lead industry. This is because, aside from its toxicity, lead is a very useful material. It's a great electrical conductor, it's malleable, has a low melting point, and is effectively infinitely recyclable. In fact, lead-acid batteries were the first kind of rechargeable battery ever invented in 1859. And to this day, lead-acid batteries still dominate the market and are the most widely used rechargeable battery. They're used in almost all forms of motorized vehicles, and they're also used as stationary power supplies, such as in telecommunications and in household off-grid solar energy systems. Compared to other rechargeable battery technologies, they are affordable with a low upfront cost, have high cranking performance for starting engines, they're heavily integrated into existing infrastructure, and they have a high scrap value. I'll provide all of the references on the last slide. Next slide, please. Globally, we produce approximately 17 million tons of lead-acid batteries per year, and there's no indication that lead-acid batteries will be phased out in the near future or next 10 years. Each battery is typically 60% lead by weight, although this can vary, so that's roughly 10 million tons of lead sold within batteries every year. That's equivalent to the weight of 1,000 Eiffel Towers, or 1.2 kilograms of lead for each person on Earth sold every year. Next slide, please. This quantity of lead is quite hard to imagine, and lead acid batteries are consumer products, so just like any other consumer product, they eventually break and they have a finite lifetime. They generally have a lifetime of between 2 to 5 years, although this depends on what the batteries are used for and the climate they're in, and they're prone to rapidly breaking if improperly used. The result is that we have several millions of tons of lead, a highly potent neurotoxin, within broken batteries, placed into the hands of consumers every year who often don't know the health risks. So what happens to all of these batteries? Lead acid batteries are one of the most widely recycled consumer products in the world. Why? Because it can be very easy to recover the lead, and lead has a high scrap value, largely driven by the demand to make more batteries. So recycling can be very profitable. So lead acid batteries are almost always recycled, and recycling is good, right? Next slide, please. Well, not always. The problem is not if lead acid batteries are recycled, the problem is how they're recycled. Lead is a highly potent neurotoxin and it's toxic to virtually every organ in the body. There's a strong scientific consensus that there is no safe level of lead exposure. Even the lowest detectable limits of lead exposure are expected to permanently impact a child's brain development, so any release of lead to the environment is hazardous. Lead acid battery recycling practices are often given the binary label of either informal practices, which are considered as unsafe, or formal practices, which are considered as safe. But in reality, there's a broad spectrum, and recycling practices can look very different, ranging from entirely uncontrolled backyard practices shown on the left, which have been recorded to release as much as 50% of a battery's lead content to the surrounding environment, then ranging all the way to highly sophisticated factories with advanced pollution control systems as pictured on the right. However, just because a facility has a license and is considered as formal, it doesn't necessarily mean that it's safe. We know that many smelters in low and middle income countries likely fall in this middle range of industrial scale facilities that have substandard emission controls, which results in a substantial flow of lead pollution from each facility. Therefore, the levels of lead pollution from any recycling practice need to be carefully monitored and regulated. Next slide, please. There's another part of the problem that's often overlooked, and that's informal battery repair and refurbishing. This is when parts of broken batteries are salvaged and used to informally refurbish batteries with rudimentary techniques. These are pictures from my PhD work in Malawi, showing people making improvised battery cells by hand. These shops typically have a much smaller scale, but are located within densely populated communities, on high streets, and even sometimes within a few hundred meters of schools. Addressing these practices will likely require slightly different solutions to regulating the industrial smelters. Next slide, please. This image gives a headline summary of the different pathways which lead may be released from lead acid battery recycling practices into the environment, and also the different pathways which people can be exposed to that environmental pollution. There are a few different processes that can release lead into the environment. Firstly, air emissions from chimney stacks, which release high temperature exhaust gases into the atmosphere from the furnaces that melt the lead. Air emissions can also be released from other processes such as battery breaking, charging furnaces, pouring molten lead, exhaust leaks, and the resuspension of dust. These other uncontrolled sources of air emissions that don't come from chimney stacks are called fugitive emissions. Fred will touch on these in the next presentation. Generally, larger, heavy particles from fugitive emissions are expected to quickly fall to the ground and show high levels of soil contamination that quickly reduce within a few kilometers of the facility. Whereas the lead emissions from chimney stacks are expected to contain fine lead particles and fumes that can stay suspended in the atmosphere for hours or even several days and can be carried hundreds of kilometers by wind. Eventually, these lead particles in the atmosphere will fall to the ground and will be spread over a very large area, landing on soil, food crops, and water bodies. There's a growing body of research that suggests that this widely spread lead pollution that lands on the surface of food crops may cause low but significant levels of food contamination, potentially exposing very large populations and posing very large cumulative health risks. This exposure pathway has previously been overlooked, but we're hoping to address this with our upcoming research. Other pollution pathways include the uncontrolled dumping of slag, which is solid waste from the smelting process that has a high lead content. Samson will show you evidence of this in Ghana. This poses a risk to local soil contamination, and this lead could also potentially leach into the water table. There's a similar risk from battery acid that's drained on the floor. Lead that's dissolved or suspended in the acid will contaminate the local soil and could potentially also reach the water table. Now, considering the pathways which people can ingest lead pollution, people can also be exposed in different ways, either through eating contaminated food, inhaling contaminated air, ingesting contaminated dust and soil from hand-to-mouth practices, which is a particular concern for children playing outside, or from drinking contaminated water. And finally, workers at the recycling facility may collect lead dust on their clothes and skin and may bring the lead home with them, exposing their families. Next slide, please. Now, what are the health risks when communities are exposed to lead pollution from lead acid batteries? Considering all sources of lead exposure, not just batteries, lead exposure is estimated to cause 3.5 million premature deaths and the loss of more than 750 million IQ points each year. However, it's still uncertain what fraction of this global health burden is due to lead acid batteries. Isolated case studies have recorded fatalities and life-threatening blood lead levels in communities surrounding lead acid battery recycling practices under the worst conditions. And a recent paper from Lee Crawford et al. Estimated that 36% of lead exposure in low and middle income countries could be due to lead acid battery recycling. But that study relied on modelling impacts within only 5 kilometres of recycling practices and gave a wide uncertainty range of 20 to 90% of lead exposure in low and middle income countries. So we expect that lead acid battery recycling is responsible for at least a large fraction of the global health burden from lead, but could potentially be the single largest global driver of lead exposure. But there are still a lot of uncertainties and the research is ongoing. We still have a lot to learn about the exposure pathways, particularly at longer distances and from food contamination, and understanding these exposure pathways is vital for us to be able to identify affected communities and to develop effective solutions. Despite these uncertainties, we know that there is no safe level of lead exposure. So any lead that is released into the environment by any pathway should be expected to present significant public health risks. Therefore, all pollution should be reduced as much as feasibly possible. Next slide, please. To effectively reduce the health burden, environmental lead pollution needs to be monitored and regulated. Specifically, it's important that governments define legally binding limits for lead contamination in air, food, soil, and water. Example reference levels for each are shown here from the World Health Organization, the United Nations, and the US Environmental Protection Agency. Part of my role at Pure Earth is reviewing if these references are effective to prevent health burdens. In particular, we believe that the codex limits for food contamination should be reduced, but in general, regulations need to be based on defined numeric limits for lead levels in the environment, and these environmental limits should be set in a way that protects the health of surrounding communities. Systems also need to be put in place to protect the people working at these facilities and to reduce the risk of them bringing lead contamination home with them and exposing their families. And of course, defining limits is not enough. There also needs to be a continuous effort to monitor that these regulations are being followed by routinely testing that these limits are being achieved. Next slide, please. Here's a list of the reading materials referenced in the slide if you're interested in further reading. And next slide, please. Finally, thank you for your time and please don't hesitate to reach out if you have any questions.
Thank you very much, Chris, for that presentation. And again, just to reiterate, if you have questions, please put them in the chat or in the Q&A as we go through. And now let's go to the next slide. And I'll introduce the next speaker, Fred Ajay, who will be talking about options for intervention to address ULAB recycling and the technical side of this. So go ahead, Fred.
Thank you, Angela. Next slide, please. Right, I'm Fred Ajay. I'm with Öko Institut. We are a non-governmental organization based in Berlin, Darmstadt, and Freiburg in Germany. And I'm very happy this afternoon to talk you through our options to have interventions for address ULAB recycling, how we work in the different countries that we work in. Next slide, please. Right. Before going into it, it's important to understand that a lot of the time in most of the transitional economies that we work in, we see a dynamic between the informal sector and the formal sector. These are not competing organizations. In fact, what we have observed is that the informal sector tends to become collectors and suppliers to the formal sector. So by targeting the formal sector who have more economic power, usually you can also effect change down the value chain. So in most areas, the vast majority of batteries are registered in registered industries. Next slide, please. Indeed, when we go to countries like Ghana, Nigeria, Tanzania, and co., the recycling facilities look like what you see in your picture. These are not small organizations or small backyard things, but they are often registered, maybe not as ULAB recyclers, but they have certificates. They are registered with EPAs and co. They may not always say what they do, but for sure, they are established businesses, often chains across the continent or with different branches in different countries. Next slide, please. Right. So why does lead pollution or lead acid battery recycling lead to pollution at all? Well, if you are a low informal recycler, you could recycle about 50 to 60% of lead. With a bit of investment, you could go up to about 90%. And then to really go to a high stage of recycling, you could maybe get about 98%, but then the amount of money needed does not correspond to a dramatic increase in lead purity. So if there is no regulation, if there is no pressure on recyclers or on the sector, most would choose to stay in the middle sector simply as an economic decision. Businesses exist to make business. If there is no push, they would simply stay there because you don't get enough money for your buck, so to speak. So if you have a formal sector that is unregulated, then indeed low standard or mid-standard recycling is highly profitable and there is no incentive to change. Next slide, please. Right. So the main document that we work with, or the main guiding document that we work with, is the Standard Operating Procedures for Environmentally Sound Management of Used Lead-Acid Batteries. This document is also the main reference document used extensively in the PLF tool that we are talking about today. And indeed, in some countries, or in Ghana, my home country, it's actually part of operating conditions for ULAB recyclers to have operating permits. Indeed, this document was developed by the SRI, funded by the Swiss, with Eurobat, Association of Battery Recyclers, also with MRI, who are here. And indeed, with this document, if it's followed, you can be sure that the practice is at least to a standard that could be acceptable. Next slide, please. Now, the SOP document it's not a document that is intended to be used to hide away from recyclers. Rather, it's supposed to be a guidance both to plant managers, regulators, and auditors. Now, it really reflects international good practice. And as I said, if it's really implemented, you could conclude that an operation is in line with international practices. In fact, what it is that most companies in transition economies like Ghana, Nigeria, and so on might not be able to comply with every facet of the SOP from day one. So the task is to see, okay, is a facility able to improve? Is there a high amount of emissions from this facility? Is there a willingness to improve, both from an economic perspective and also from the attitude? Are you able to develop an improvement plan? So therefore, you look at technical feasibility, economic feasibility, willingness to actually make those changes, and then you kind of classify the facilities that you would assess with such an SOP, and then see whether what would be the most appropriate course of action. Of course, under severe situations, then revoking of the operating license or closure of the facility is recommended. However, there's a caveat. I think that's in the next slide. Next slide, please. Now, we as Öko Institut, being a German organization, cannot go to Ghana or Nigeria and go to a recycler and say, open up your door, let us look in your facility and do this, don't do that. And if you are doing that, you're closed down. We have no locus, we have no mandate. So the first thing to note is that in working within such a context, there needs to be a high level engagement with agencies that indeed have that mandate to monitor the sector, to say, hey, we are here for facility assessment. This could be an EPA, an Environmental Protection Agency. This could be, in some countries, as a Ministry of Environment. Some it's a Ministry of Trade and Industry. Every country has, or geographic area has its own peculiarity. So it's important to understand that. Also, indeed, the SOPs or the assessments are meant to be sharing of know-how, lessons learned on sector reform from different areas. For example, you would find similar dynamics in West Africa, similar, maybe somewhat a bit different in East Africa, but largely you can compare. And indeed, all assessments that are conducted would lead or should lead to a specific improvement plan that authorities can use. They can take the document, they can put their stamp on it, and they can use that for their follow-up, for their enforcement, also for informing further assessments that they would undertake. Next slide, please. Right, so how does a facility assessment actually look like? So I'm gonna ask everyone, let's get into a bit of an imaginative mode. Just try to imagine it a little bit. We have gone to a ULAB facility, we are at the gate, they've let us in, what happens? Well, you would have an introductory meeting. And at this meeting, you kind of wait for a safety induction. My little trick is to say nothing and to see if a safety induction is offered to me. That tells me, they are thinking about safety already. It tells me what's the culture here, what's the mood here. So you would have the introductory meeting. God willing, you have been given a safety induction, you have a nice helmet, you have some reflectors on you, and they tell you, here we can go, this is what you do in our facility, follow us, and we take you step by step. Now, usually you'll be taken to the battery breaking section where you will see batteries being broken either with an automated hammer mill breaker or by hand or with some blunt object. And then from there, you would see what happens to the battery acid. Is it poured on the ground? Is it going to a waste acid treatment facility? Is it being made into gypsum? How are the plastic casings when the battery is being treated? Are motorcycle batteries being separated from vehicle batteries? These are different kinds of plastics. We talk about ABS plastics and polypropylene plastics that should not mix if you're going to recycle. So from there, you will see how the lead charge is what goes into the smelter to be melted, and then you get your lead out of it. So you want to see how that's being done. So from there, you would walk to stage 4. As you can see there, you go to the furnace area. It's very likely a large area. You want to see how this is being put in there. You want to see whether the furnace is enclosed, whether they have technology or pollution control systems to suck emissions during charging. Charging is when you put the lead material into the furnace to melt it, and then when it's done in about 2 hours or 6 hours, depending whether it's pure lead or lead oxide, you are going to tap it. Tapping is you have molten lead, there's a hole in the furnace, and then this molten lead comes out. Now, these two activities are the highest points where you would have emissions, when you're putting lead in and when you're getting molten lead out. So you want to see in that furnace area, how is this being done? What are the pollution control systems? In the lead world, we call these off-gas treatment systems that would pool this for treatment into cooling towers, into scrubbers, into baghouses, so you can get lead dust, which will be charged back. Right. So let's say we've checked the furnace, we would go into refinery. Now you have bullion lead from the furnace. Maybe it's 96%, 97%, but you want 99.99%. Maybe you want a certain alloying element. You want a little bit of this, a little bit of that. That's where they do all of that. Now, in the refinery, you have a bit of emissions. So the refinery is like a big cooking pot, and you have molten lead in it, and still you have some emissions. So you also need pollution control systems there that would also take this out into an off-gas treatment system. So from refinery, you have refined lead, it's flowing, and then it's being cast. Now, the question is, how is it being cast? Is there maybe a water spray to cool it down? You want to see that it's being done in a way that people are not going to get hurt, but it's not a major thing. But you still want to see how this process is being handled, how scraps that are falling off being fed back into the furnace. You want to see how the finished product is being stored. Is it orderly? Is there no tipping hazard? Last but not least, you want to see slag. This is a byproduct of the smelting operation in the furnace over here. You want to see how this slag is being handled. Is it being stored somewhere concretized? It's not leaching into the ground. It's not exposed to the environment. You want to see how that's being handled. You want to ask questions. Where is the final disposal? Is it in an environmentally sound landfill, or is it going into some other approved process? You also want to check amenities. These are facilities for people to take a shower, to change their clothes. Is it designed in a way that you are forced to enter, change into working clothes, and then from work, you go towards the amenities. You can change into your home clothes and not have take-home lead, as Chris was talking about. You want to make sure that there is that kind of human-centered design around this, right? You also want to check the canteen. How are people able to have lunch? Is it also separated from the main recycling area? So you want to take a look at these things a bit more detailed. We cannot become experts here, but I hope this gives you an idea. Next slide, please. Right, so this is battery breaking. You go to a facility like this, and straight away, what do you see? You see that the floor appears to be not concretized. There is some liquid there that tells you, okay, acid is leaching. There does not seem to be any machine for breaking, and there you can see that people appear to be breaking with blunt objects. You can see that there's not good personal protection. So immediately, you know this is below a safety standard. Next slide, please. Right. Now, these are plastic casings. You can see that it's a bit covered, but not so well covered. You can see the brown marks on the wall here. This is just acid leaching down the wall. And because it's acid, it's going to discolor the walls. There's no way to hide this. So you can see, ideally, this should be covered. It should be washed 3 times, and including an alkaline wash to really get off any particles of lead still attached to the plastic. Next slide, please. Right. Now, this is a furnace. The furnace is a round, usually it's a rotary furnace. There are other kinds of furnaces, but in transition economies, usually you're going to see a rotary furnace. You want to check that it's enclosed, but then most of the time they know you're coming, so they are not going to be in operation. Yeah, everybody has holiday. Something has happened, or maintenance. But how do you know that when there's charging and tapping, whether there are emissions or not? You can tell by the scorch marks on these points. This is the charging port, and you can see the telltale signs, this blackening over here, that when you are charging, there are likely emissions. Also, same here at the tapping port, you can see those telltale marks, which are very hard to hide. So indeed, it's rather transparent for all to see. Next slide, please. Right. Now, the picture on the right, you can see some batteries have been stacked, and you can see some powder on the floor. This is most likely caustic soda used to neutralize acid spills. So they know you are coming, and they want to say that there are no acid spills. But then you go and you see this. This is a clear indication that there are indeed spills, and these are attempts to cover them up. Now, the picture on the right, this is a baghouse where you have, as I mentioned, you have an off-gas system. You have gas being directed through that. You have lead particles in there. And as they go through cooling towers, these particles cool, and then they just cycle down like that. What you should see is that this bucket should be closely under this collection hub, let's call it like this. You should not see any kind of dust, but if you look closely, you can see that it's not properly there. There's no way that dust is not escaping. If you look closely at the picture, you can see that somebody has tried to use a broom to do their very best to clean up, but the marks are there, and this tells you that usually you would have a lot of dust in this area. So you can see there is something finicky happening over there. Next slide, please. Right, this is a refining kettle. As I said to you, imagine a big pot. Now, where I have circled, you would have expected to see a contraption, like a big tube with a pump that would suck out any particles that might be escaping. We're talking about molten lead. So for refining, maybe around 550, 600 degrees, maybe 650, depends on the alloying elements. It's not that high, but you will still have some lead particles escaping because it's liquid at this point. So once you see it open like this, that tells you indeed they are simply refining and just mixing things up like a huge pot of food, basically. So there is no way that there's any kind of pollution control in a facility such as that. Next slide, please. Right. Now here, what I wanted to show was management and worker attitude to safety. It's very general. This is a fellow inside a laboratory furnace chipping at lead inside the facility. That cannot be safe. You can see that he's scantily dressed. He has no nose mask. You want to see whether workers have masks on. You want to see whether there are records of blood lead levels for years, not just one time, because you're coming to check. You want to see how management addresses safety. You want to see signs on the walls. You want to see adherence, not just for show, but just to also tell you what are the safety standards being done. So I hope these are not too deep, but enough to give you a feeling. What does it take to assess a facility? And what does it mean to say a facility is below or above standard? I hope this is good enough. Next slide, please. Yep. Thank you very much for your time. And here my email. If you have any questions, I'm happy to answer them by here or by email later. Thank you.
Thank you so much, Fred. I think by now we can all do an inspection very well. Thanks. Wonderful presentation. Next slide, please. Now we're going to change gears and look at policy options for interventions to address ULAB recycling by Tom Daniels at LABRI. Go ahead, Tom.
Thank you, Angela. So I'm Tom Daniels, Co-Executive Director of LABRI. LABRI is a policy organization that works to reduce lead pollution from used lead-acid battery recycling, and we work primarily in Southeast Asia. I co-founded LABRI with Michaela Rogers, who may be appearing in the chat to answer questions about the tool as well. So just wanted to flag that. In my 10 minutes, I'll focus on the national policy levers that governments can use to reduce unsafe recycling and some of the considerations that governments might take into account when deciding which levers to deploy. Next slide, please, Kennedy. Next slide again, please. Great, thank you. The core point that I wish to make during this presentation is that ULAB markets differ considerably between countries, and policy solutions should differ as well. That is why the tool itself is structured in two parts, with the first focused on understanding markets and the second focused on best practices and strategies. I saw the need for this understanding of a market in a recent project that we worked on. We were approached by a government in a low-income country asking for support to address high levels of backyard, small-scale smelting. The relevant ministry was focused on this issue because research that they had done in the early 2000s had identified several small-scale backyard smelters. However, when we worked with a local consultant to do supply chain analysis, we found that backyard recycling was not the problem. In fact, smelting was actually concentrated in a few large, unlicensed industrial facilities. The solutions for backyard recycling differ from those that we would suggest for a more consolidated market. So this was a case where up-to-date, accurate information about ULAB markets was absolutely crucial to finding the right solution. Next slide, please, Kennedy. In line with this point, I set out in this presentation 3 key problem types that stakeholders might encounter in ULAB management. These are covered in more detail in the tool, but in this presentation, I wanted to outline categories of solution for each problem type and discuss what regulators should consider and how they might measure success for each policy solution. As I say, this summarizes a lot of the content in the tool itself. Next slide, please, Kennedy. The first problem to discuss is informal recycling. By informal recycling, what I mean here is unlicensed recycling, which isn't subject to any supervision or monitoring. Informal recycling is inherently unsafe because of this lack of monitoring and supervision. And so where authorities find informal recycling, they should consider pursuing measures that ensure all ULAB recycling is licensed. This generally consists of 2 steps. The first is establishing a licensing regime. If a regime does not already exist, authorities can look to international examples or best practice guidance, for example, from the Basel Secretariat, to understand the requirements that they might apply to ULAB recyclers. In most cases, though, and I think Fred might have referred to this, authorities will not need to start from scratch before setting up a regime. Often there will already be a regime in place for hazardous waste management, and ULABs will be covered as part of that. The second step in addressing informal recycling is around incentives. It is often not enough only to license ULAB recyclers. Authorities must also consider putting in place measures that ensure that formal recycling is more economically attractive. In many contexts, informal recycling persists because informal recyclers can offer better prices than their formal counterparts. There are a couple of measures I want to pull out particularly on this. Extended producer responsibility schemes can counteract these incentives by making producers legally responsible for ensuring that the ULABs they produce are recycled in formal settings. The second policy within this category is deposit schemes. These place a refundable deposit on the price of new lead-acid batteries that can then be refunded when they're returned to a collector or recycler. Next slide, please, Kennedy. When considering what policies to pursue within this category, authorities should consider a few key questions. First, how many producers of new lead-acid batteries are operating in the market? A more concentrated market may make an EPR scheme easier to operate, whereas a highly fragmented market may mean that other measures are more feasible. A second key question to consider is what regulations exist for new lead-acid batteries. If authorities already specifically monitor and tax new lead-acid batteries, for example, a deposit scheme could be integrated into those existing systems. It's important to monitor the success of any of these interventions, so I've also outlined some key metrics here, which I won't go into, but these are also covered in more detail towards the end of the tool. Next slide, please, Kennedy. The second problem type I wanted to discuss is pollution by formal recyclers. This is already a point that has been made by Chris and Fred. Many countries may already have licensing regimes for ULAB recyclers, and a lot of recycling may happen within those formal facilities. However, formal recyclers can still be causing large amounts of lead pollution if they don't adopt the correct practices. I set out three categories of solution to this problem. First, in-facility improvements. This means identifying priority areas of non-compliance through visual inspections and then requiring and monitoring those improvements. There are several strong existing resources that regulators can use to conduct inspections, including the SOPs that Fred has already mentioned. I also won't go into these in any more detail because Fred has already covered them in a lot more detail. The second category of solutions is around setting minimum equipment requirements for new plants. Currently, plants are often licensed without the equipment to operate safely, and regulators should ensure that they check machinery and pollution controls during the actual application or licensing phase, and then only license applicants that meet that standard. This can mean that recyclers that are unable to operate safely because they don't have the correct equipment are not able to begin operating. The third category of solutions under this header is around relocating or closing plants. There are examples of licensed ULAB facilities operating in residential areas, and there was a very public example of this in Kenya in recent years. Where ULAB facilities do operate in densely populated areas, that means that any pollution those facilities generate can affect many thousands of people. Regulators should consider working to relocate any facilities in densely populated zones to different areas. I should say before moving on that these three categories of solutions are not mutually exclusive. An approach that combines these different streams will often be necessary. Next slide, please, Kennedy. The main questions that regulators should consider here relate to the status of existing sites, really. One key question is about how big existing sites are and where they are located. This will influence whether relocation or zoning measures are necessary. A second key question is about what equipment formal recyclers currently have in place, because this will influence which improvements are necessary. Next slide, please, Kennedy. The final problem that I will cover more briefly, and which is also discussed in the tool, is about the use of low-quality lead-acid batteries. We found in our research in one sub-Saharan African country that lower-quality lead-acid batteries could last half or even a third of the duration of higher-quality lead-acid batteries, and Chris also referred to this. If low-quality lead-acid batteries like this are common, that can mean that the total number of used lead-acid batteries being recycled is considerably higher, and therefore that the lead pollution from lead-acid battery recycling is also higher if that is happening in unsafe conditions. Policy responses to this problem should depend heavily on the particular reason for the use of low-quality lead-acid batteries. So in some cases, price might be the key driver of people buying low-quality lead-acid batteries. In those cases, regulators might consider adopting schemes that make higher quality lead-acid batteries more attractive. So kind of borrowing or lending schemes that subsidize higher quality lead-acid batteries. In other contexts, it may be that consumers are simply unaware of how long low-quality lead-acid batteries will last, and recent research conducted in Bangladesh has indicated that this is a dynamic playing out there. In cases like that, regulators might consider pursuing information campaigns or other measures to ensure that consumers are aware of how long batteries will last. I will also just cover one potential other solution here, which is product standards for new lead-acid batteries. What I mean here is that regulators might consider imposing minimum standards for new lead-acid batteries entering the market. These measures can ensure that long-lasting batteries are more common, so those that are imported and those that are manufactured are meeting certain standards. However, these measures will only work if they're accompanied with appropriate monitoring and enforcement. This can include testing for the life or performance of batteries kind of on an ad hoc basis, and then confiscating batteries or consignments of batteries that don't meet key standards. Next slide, please, Kennedy. Actually, I've already covered this. So next slide again, please, Kennedy. That brings me to the discussion of the 3 policy solutions that I wanted to outline and which are covered in more detail in the tool. There are 3 key takeaways, though, that I want to leave you with today. First, information gathering is critical to effective policy design, and solutions have to be context specific. That's exactly why the tool is built around understanding the market before designing policy. Second, incentivizing formal recycling is often an important aspect of safe ULAB management, but it isn't always a complete solution. Many formal recyclers are significant polluters, so formalization is often the start of the work, not the end of it. Third, every policy needs to have a monitoring mechanism, and the tool includes suggestions for different metrics to monitor. However, in a lot of cases, this monitoring won't require building something new. Hazardous waste manifest systems, customs data, and product standards bodies often already exist in the countries which are being affected by these problems. In our own work in the Philippines, we found that involving customs and the Departments of Trade and Industry in the policy development process has been very helpful in making sure that existing infrastructure is leveraged. Next slide, please, Kennedy. That brings me to the end of my presentation. If you have any questions about anything that I've said today or about Library's work in general, please do drop me an email at this address. Thank you. I'm looking forward to the further discussion.
Thank you very much, Tom. And again, thank you to Tim and to you and Michaela for being the lead authors on this tool. Next slide, please. Now we're going to turn to our country case study that's being presented by Dr. Atiemo Sampson of the Mountain Research Institute, and he's going to talk about the policies and practice in Ghana. Over to you.
Thank you very much, Angela, and good afternoon to everyone on this webinar. Next slide, please. My name is Samson Atiemo, as has been mentioned. I'm coming from Mountain Research Institute. Next slide, please. We are a wholly Ghanaian-owned institute, and we operate within the space of circular and sustainable cycles. And we have been working on ULAB issues for almost 2 decades. Next slide, please. This afternoon, I'll be taking you through the value chain in the ULAB sector and how it plays out also in the international market. So when you start from collection, there are companies that collect the ULABs and then export them with the acid to the international market. There are also companies that collect but drain the acid and then export. Some break the batteries, extract the lead scrap and export, and then sell the plastic casing to the local market. Then we have the ULAB smelting companies. They take the batteries, smelt get the raw lead ingots and then export them to the international market. I must state that there is also a small domestic use of these batteries, and mostly they come from informal smelting. Chris mentioned battery repair and refurbishment. During the repair refurbishment, the repairers need the battery terminals, so they depend on informal smelting to get the terminals. Also, in the fishing sector, lead is used as a weight for the nets. So some of the informal smelting of lead goes to the fishing sector for the fishermen to use in their nets. Next slide, please. Next, okay. Now, when it comes to the collection, especially for the large-scale recycling, the recyclers and exporters normally demand drained acids. So in the photo, you see acid collected and stored, and they are normally cut for the drainage of the acid. The top right corner picture, you see yellow gallons over there. These are gallons that are used to collect the acid. Sometimes they sell some of the acid openly in the market. Other times they just pour them in the drain. So on the picture, on the down right corner, you will see a drain there, a municipal drainage system where the acid is drained and they are allowed to flow and join the normal municipal waste flow system. And these practices are normally driven by the formal sector, that is the recyclers and exporters who demand drained batteries from the informal sector collectors. Next slide, please. When it comes to transportation of ULABs, I must say that the transport is done in any manner at all in Ghana. And so on the left picture, you will see acids arranged in a semi-truck, and this is just a push cart by individuals. They push them to their collection center, and that is where they do the cutting and drainage before they send them to the facilities. Also on the right-hand side, you see a photo of a truck, and this truck, the batteries are arranged in any manner at all. Some of them are cut before the drainage. You see on the floor there, very wet floor. This tells you that the acids have been drained in this floor before they are loaded onto the truck. Some of the transporters have complained that the transportation of these wet acids normally affect their vehicles. Next slide, please. When it comes to the recycling sector, in Ghana, we have the best and the worst of two worlds. So you have good plants and plants with unacceptable practices that are operating side by side. And so on the left-hand side, you see a rotary that is smelting the acid and smelting the lead, and you could see the front open. And if you observe carefully, you see smoke coming out, and some officers trying to check whether the ventilation system is working or not. Of course, a rotary like this does not need a ventilation system because the smoke comes out anyway. Then you have plants that have good standards also operating in Ghana. You look on the right-hand side, you see a photo of such a plant, very beautiful design from the outside. Okay, next slide. Now, in Ghana, we still have problem with sludge management, as was alluded to by both Chris and I think Tom. The sludge coming out of the recycling processes are disposed on the normal municipal waste dam sites, where you have waste pickers who go there and try to sift through these sludge to find some metals for sale. We do not have an engineered landfill site for disposal of this high level of hazardous waste. And so the companies resort to the normal municipal waste dam site for the disposal of the sludge coming out of ULAB recycling. So having seen these challenges, the question is, what are the options? What are the practices that government is adopting in addressing these challenges? And I'll walk you through a few of them that we are doing in country. Next slide. Now, to address this challenge, the first attempt by the Environmental Protection Authority and the Department of Factory Inspections was to conduct what is called a BAT assessment with the support of the International Lead Association and the Sustainable Recycling Industries Project financed by the Swiss government. So industry and regulators came together to audit all the facilities, and we saw some of the worst practices. As you see, a man holding cutlass on the top right corner, doing the cutting, and also off-gas systems of a plant, and the sludge that is scattered all over. This was the state of some of the plants at the time this BAT assessment was done. Next slide. Now, following the BAT assessment, Kennedy, can you take me to the next slide, please? Good. Following the BAT assessment, no, please. Before this one, sorry. Yes, thank you. Following the BAT assessment, the Environmental Protection Authority and the plant managers came together to sign what is called the improvement agreement. And in this agreement, a few steps were outlined to help resolve some of the key challenges that the plants were facing. At the time, we did not have the TENCA guidelines, so this improvement marked a very important step in addressing some of the challenges that we had in the sector. Next slide. Now, again, following legal action by a nearby company, in this case, there was a plant called Gravitas, which was very close to another company, Air Liquide. The Air Liquide company conducted blood lead levels for their staff and realized that there were very high levels of lead in the staff, in the blood of Air Liquide staff, though they are not workers of Gravitas. So Air Liquide took legal action against Gravitas and EPA. Following that legal action, the Gravitas plant was shut down by the Environmental Protection Authority, and they relocated to another site, now bearing the name Recyclers Ghana. Next slide, please. So shutdown has been done by Ghana in the past. Again, as Fred mentioned, with the kind support of the Sustainable Recycling Industries projects and able support from partners across the world, we developed what we call initially called the Standard Operating Procedures for ULAB recycling in Ghana. However, after the development, the Environmental Protection Authority thought the document was more than just an SOP, so the authority converted it into what is called technical guidelines for ULAB recycling in Ghana. So if you hear technical guidelines for ULAB recycling in Ghana, it's the same as the Standard Operating Procedures. However, there are more Ghanaian laws in this one. Now, this guideline, as Fred mentioned, is a mandatory technical guideline for all ULABs. It's mandatory for all ULABs. So if you want to set up ULAB facility in Ghana, you would have to follow what is in the technical guidelines. And I will encourage audience to go online and read what is in this document, but has been explained by Fred. Kennedy, next slide. Another key policy step has been building capacities across the value chain. ULAB has been one of the most polluting industry in Ghana, and you need capacity for both industry and regulators. And so governments took key interest in building these capacities, especially for the staff of the Environmental Protection Authority, for the Department of Factory Inspectorate, some selected municipal assemblies, the National Fire Service, and a host of other stakeholders that needed capacity to support the management of ULABs. It's still work in progress because more capacity is needed. A lot more capacity is needed for us to come to that level of conformity that we can describe as maybe better than we met it. Next slide, please. Whilst we are at it, whilst we are developing all these processes, in 2023, the Environmental Protection Authority got busy In this picture, you see the former executive director, Mr. Kwabena Kokofu. He got busy with the ULAB plants and actually went into some of the plants. In one day, he shut down 2 plants because of their unsound processes. Non-ferrous and Success Africa plants were shut down by the Environmental Protection Authority. I was part of the team that went in to do auditing of these plants as a precondition for their reopening. And I must say that some of them really took the shutdown serious and improved the operation. But the key thing is that we must shut down bad plants so that the good ones will have the leverage to operate. The government also noticed that, next slide please, there is still capacity gap in the management of ULAB, especially from regulatory perspective. Kennedy, if you can take me to the next slide. And so there are 2 key, thank you, there are 2 key institutions that builds capacity or trains, or please, before this one, the previous one, sorry. Good, thank you. Yeah, this one, good. So the 2 key institutions are the schools of hygiene. In Ghana, the schools of hygiene are the main source of training environmental health officers for the municipal assemblies. And these officers, after they go through 2 or 3 years of training, they are posted to the municipal assemblies to help in managing the environment. And so with the support of GIZ and other partners, we're able to incorporate electronic waste, including ULABs, into the curriculums of the schools of hygiene, so that these become a subject that they are taught in the school before they pass out to join the municipalities and help. We think that by introducing the curriculum at that level, we'll be able to maintain knowledge and retain capacity before the students come out as professional regulators. The other institution is the technical training institutions. And these are pre-tertiary institutions that are helping to train junior level staff. And so what we have done is to integrate e-waste into the curriculum called recycling technology. And in this recycling technology, ULAB is one of the key technologies we are teaching the students. The hope is that once they pass out and they get employed by these recycling companies, they will be able to, they will know at least the basics of some of the safety and the technology needs of the sector in order to improve knowledge and capacity for ULAB recycling. Ghana currently have 5 big recycling companies, though 2 of them have shut down because they are not getting materials. The other 3 are still operating, and we need to provide professionals who can join the sector as employees in the future. Next slide. For me, the key question is, why should unsound practices happen? Why should unsound practices happen when you have good plans that are operating in the country? I have shown from the right-hand side a company that had a hammer mill for cutting the batteries. They were using conveyor system for the cutting, and there was not even a single drop of acid around their cutting area. They had a state-of-the-art technology just for the cutting. However, because other companies were allowed to operate in an unsound manner, they now have open cutting of the batteries, as shown in the top right corner, where I believe you can see me standing conducting audit for this facility. You will see that they are doing the cutting in the open, acid all over the place. You also see informal smelting of the lead that I mentioned. So for this company, the business model for them will be, if you can't beat them, then you join them. If you can't beat them, because the companies with unsound practices are able to pay higher fees for the batteries. where the companies that have the latest technology are not able to compete on the market. So they try to cut back the competition by lowering their standards and making more savings to buy the batteries. In Ghana, we have seen a good plant shut down because they cannot compete. And a typical example is Gold Line Recycling. This was a company that were even converting the acid into gypsum. But because other plants were operating unsoundly, they could not beat them in the competition, and so they have to fold up. And this is what we must all help to prevent from happening. I think next slide. So that's the end of my presentation. Thank you very much. Angela is already here. So Angela, thanks. And thank you to all the audience.
Thank you very much, Samson, for a great presentation about your experience in Ghana. If all panelists want to come on camera, we've come to the point, next slide, please, Kennedy, where we have an opportunity to interact with you. If anyone in the attendee side of things would like to ask any questions, please raise your hand and I will unmute you. Otherwise, also type in chat if you prefer, or in Q&A. I'll refer you to the Q&A where some questions have already been asked regarding the most recent about what about other areas of the world, such as Pakistan. So there's an answer there about work in Bangladesh and India. So take a look at that. There were also other questions about what types of policies and impacts of lead-acid battery facilities. So if anyone has any other question they would like to ask the panelists, please do so now. Otherwise, I will ask them a question. Anyone like to ask? Please raise your hand. All right. Well, if something comes to you, don't hesitate to put it in chat. So I'm going to turn to Fred first and pick your brain for your knowledge of looking at these facilities and ask you about approaches you've seen that have been the most impactful and effective at reducing lead exposure at ULAB recycling facilities.
Okay, thanks, Angela. I would say the first one would be the standard operation procedures, as I talked about. In a lot of countries, there are actually quite good laws, or at least there's a law that says a factory must operate in an environmentally sound way or something like this. But most laws do not go into detail. So the SOPs have been a game changer that, you can take it and say, okay, do it like this, do it like that, you will get that result. And it really gives clarity to recyclers as well. What shall I do to prove that I am doing my very best? And also to auditors and to policymakers to say, okay, what am I going to check? What does it mean? The next point would be the facility level assessments with improvement plans. It's important to really look at a facility, really look at the specific circumstance. Where are they located? What process are they using? What technologies at play there? At what stage are they? And to say, okay, what is the most important thing to be done in the next month, in the next 3 months, 6 months? What can wait and what needs immediate attention, or what should be shut down now? So these are important characteristics to see. But in Nigeria, for example, we tried something where you positively list a responsible recycler. So recyclers who are doing well, who are trying their best, get a boost up. So the international community can say, okay, maybe we buy lead from that recycler at preferential prices. A bit going towards Samson said, such recyclers are struggling. So how to keep them in business whilst also given an incentive to others to say, look, taking care of environmental costs, also worker protection and safety, does not necessarily mean a dip in revenue or that you're going to go into the red. So this was very good. And then, of course, one big factor was, which is not entirely in our hands, it's in the hands of agencies with the mandate to cause change, for example. So closing down highly polluting plants. If there is no enforcement, all of this is talk. All of this is very fanciful report writing and really leads nowhere. Really, one of the big game changers is when you close down highly polluting plants. These are profitable plants. And if they're shut down for some time, it begins to bite. And suddenly you make the cost of non-compliance higher than the cost of compliance. This is a big game changer. Of course, another situation we experience in transitional economies, every government wants to see industry. Everybody wants to see growth and new jobs created. However, if you don't limit the number of recyclers, you have the situation that everybody is fighting for a limited number of ULABs. There are only so many ULABs on the market. So when you have that kind of pinch, recyclers then try to find innovative ways to maximize profit. So really limiting the number of recyclers is also an important factor. Yeah, I think I would leave it there and see if others have something more to say. Thank you.
Great. Thank you so much for that, Fred. Appreciate that answer. And we also have a hand raised. So I'm going to actually unmute Mfumu. Please go ahead and ask your question. And introduce yourself, please. I've unmuted you. Can you try speaking? Perhaps that was an unintentional hand. If you have a question, please put it in chat, and we will answer your question or raise your hand again. Oh, there you are. Please go ahead.
Sorry, can you hear me?
Yes, we can. Go ahead.
Okay. Yeah, my question was to Samson. So my name is Mfumu Kuseni. I'm working with GIZ in Malawi. So in Malawi, we don't really have a formal way of recycling lead acid batteries. So I just wanted to know how they coordinated with GIZ. I think you had said something regarding GIZ on how they contributed to the mitigation of lead acid batteries or that waste. So I just wanted to know that. I think maybe you can just briefly explain now, and we can have a call separately later. Yeah.
Sure. Yeah, I'll be more than happy to have the call later. However, with GIZ, we co-developed curriculum for technical training institutions. And these are what I mentioned are pre-tertiary institutions where their curriculum is mainly TVET, technical vocational education and training. So we incorporated a new course within the TVET known as recycling technologies. And the curriculum was developed together with GIZ. So in the development of the curriculum, we took advantage of that and included recycling of ULAB as a technology in the curriculum. Thank you very much.
Thank you very much. I think I'll get your contact from one of the hosts, and I think if I have any further questions, I'll try to reach out to you. Thank you.
More than happy to respond.
Thank you, Mfumu. Yes, we'll put you in touch with Samson. Great. Good question. Okay, we have some questions in chat. Oh, okay. Just some comments, and we have a question in the Q&A, which is open, but perhaps we could address it here. From Barakat, what types of practical incentives can be introduced to support and promote environmentally sound and compliant recycling facilities? So what are incentives that can promote good recycling? Michaela, please also answer in chat, but if anyone would like to take that idea, perhaps Tom, you've been thinking about incentives?
Yeah, I'm happy to start, and then I think Michaela has also said she'd like to answer. So
okay,
I'll see if she wants to add anything. I think the first thing I would say on this is that it's very, very important to identify who those compliant recyclers are first before designing any incentives. So Fred mentioned the work they did in Nigeria to list out the recycler that they considered to be positive. And then I think there were a number of things that policymakers can do to try and incentivize better practices. One is to make sure that it's only the good recyclers are licensed, so shutting down or delicensing bad recyclers, and then putting in place measures that mean that recycling at those places is more economically competitive. So one thing that multiple countries have done is exempt used lead acid batteries from sales tax, to ensure that formal recyclers are able to offer prices that are competitive with unlicensed or informal recyclers. There are other things that we've had conversations with policymakers around, but I've seen less public discussion of, around putting in place subsidies for equipment that a safe, environmentally safe recycler would have, or for electricity that certified recyclers have, because energy costs are often quite prohibitive to operating safely. Michaela, is there anything you wanted to add here?
No, that's all good. Thank you.
Maybe, Angela, can I ask perspective from Ghana on the
Absolutely.
incentive issue? In Ghana, we have the e-waste fund from Act 1124, Environmental Protection Authority Act. And in there is an eco levy that is paid for the importation of electronics, including batteries. Now, the thinking around is what do you do with that eco levy that is collected at the ports on batteries, because there is very high competition for batteries in the country, especially end-of-life batteries have become maybe the next black gold. And so the question is, if you put incentives on these batteries for some recyclers, are you not going to distort the market? However, the e-waste fund wants to pilot collection of batteries by itself, maybe offering a slightly higher price for batteries with the acid and mandating companies to recycle them, and also show how the acids are managed. Currently, the assessment is ongoing, and we are supporting the e-waste fund to see how they can set the criteria for the collection and recycling of these batteries. That's what I wanted to add.
Great, thank you very much. That was great to hear from the country context as well. I see we also have another raised hand, so I'm going to go to you and it's hard to scroll through this. Bear with me for a second. Oh, here you are. All right. Oluwasitan, please. I've unmuted you.
Hear me? Yes. So my name is Dr. Kuti. I believe
yes,
you can
go
name
ahead.
me. Thanks so much. And thank you so much for this wonderful panel. I think my question has like a threefold. The first one, very quick, which I failed to get. Where are all these batteries coming out of? Lower medium income countries. Where are they getting? Where are the destination? We're bringing all these batteries from Ghana, Nigeria. Where are they going? And where is there some form of responsibility of these destination countries to ensure, some forms good environmentally sound recycling practices from their origin? Secondly, Fred, I'm really interested in how, in practical terms, applying these tools in country, maybe as a facility level or as a country level. How long does it take in terms of the size of the team, the number of days to be able to apply these tools, maybe on the facility or maybe like 5 facilities in a week? How long does it take in terms of resources? Because I think that's also very important in engaging with the regulators. And I think my last question, really in a way, Tom talked about it, is the issue of licensing. Because I think the issue of licensing is a way to actually, put some form of incentive for whether medium scale or high scale recyclers, because I think a recycling plant should not have a license in perpetuity, but that license should, on a regular basis, should be reviewed. And if the company is not living up to what is expected, the licensing can be withdrawn. So I think licensing itself, I would just like to hear the views of the panel in terms of, because these are business units, and for you to operate in any country, you must have a license to be able to operate. What's the role of licensing as a form of incentive? Thank you so much.
Great, thank you, Kuti. So it's 3 parts. It's basically the flow of the batteries, where they're from, where they're going, the time it takes I guess, to regulate or to have improvements. And then finally, the licensing. Who would like to take that?
I can start.
Okay.
Where are the ULABs coming from? Well, first, they are from vehicles. Yes, I would say that batteries are from Europe, but that's too simple. Vehicles from Europe shipped into Africa come with batteries. However, batteries tend to die and they are replaced. They are also imported as new products, not as waste batteries. It's illegal under the Basel Convention. You need PIC and all this. It's not happening. So a lot of them are from cars, from used cars, also from battery replacements in country. In West Africa, also East Africa, because of temperatures, batteries would last 2.5 to 3 years. 3.5 is if it's really good, but I would say 2.5 to 3 years is the average. You have also a lot of batteries from renewable energy sectors because batteries are being used as energy storage. Also, when you talk about second life solar panels or solar panels in general, a lot of ULABs are used for this because lithium-ion batteries are not that stable and do not last very long in those temperatures. As to where lead is going, it's going everywhere. A lot of lead produced in West Africa goes to India, goes to America. Some also go to Turkey, and then from Turkey it's just a short hop into Europe. Lead is such that once it's melted and you put them all in a box, there is no way to tell that it came from this smelter or that smelter. It's not possible. If you put a tracker on it, it will block it. You can't put that kind of digital product passport on it. So it goes kind of everywhere. How long does an assessment take? It depends. You can make a quick assessment in 2 to 3 hours. It depends on the size of the facility, how dispersed it is, the design. So you could, if you want to spend time assessing every single document, you could waste a lot of time there, or you could ask for that in advance and check licenses and so before you are there to make it faster. But if you want to have a full assessment, actually that could take a whole day because smelting could take 6 hours or more. So if you really want to observe the whole chain, you're talking a whole day, 8 hours, effectively sit there and just watch everything. But you can infer, as I showed, with some know-how in 2-3 hours, you have a fair idea what goes on in a facility. It's not so much you can hide. Size, it depends who has the mandate to be there. In some countries, the mandate is dispersed. You have one organization for fire, one for worker protection and occupational safety, one for environmental protection. So it depends on that country, it's country specific. So usually you would need maybe the national regulator, the environmental ministry, the local assembly, or that kind of decentralized structure. So it's important to first, before you try to do anything like that, conduct a really good stakeholder mapping. Before you get there and the facility manager says, you don't have the mandate to check this, and I don't have to listen to you at all. So I think those are the first two questions, and I think the last one was on licensing. I think that's for Tom. No?
Fred,
Yeah. Okay,
Fred, can I just chip in one thing about the time it takes? Also pay attention to the fact that there is air quality monitoring, and it depends on the technology. Maybe you have to do the air quality monitoring for 24 hours or 8 hours or whatever it takes. And then also soil analysis, which could also take some of the time in the laboratory. Yeah, these are the two I'm adding to what you have said.
It depends on the scope. Yeah.
So Tom, go ahead quickly on licensing. So we have 2 more questions to get to. Go ahead.
Yeah, sure. Just very quickly, I think licensing is absolutely critical, basically for 2 reasons. One is that authority to monitor and sanction comes from the having of the license, and that's often connected to the mandate of the ministry. So it's really important that large facilities are licensed, because then they can be supervised effectively. The other critical thing, and I think this is the whole thrust of the work on the SOPs, the work on monitoring, is making sure that the licensing regime actually works and that the standards that are included in the licensing regime are being enforced effectively, because then the incentives that I mentioned for the last question, only then can the incentives that I mentioned for the last question really work. One final note is just to say that I think it's also critical to make sure that the correct license is being applied for. So we see a lot of contexts where ULAB recyclers need to receive a Ministry of Environment license, but in practice, all they have is a trade and industry license. I think, Fred, you referred to this as well. So ensuring that the correct agency is licensing the ULAB recycler is really important.
Great. Yes, thank you very much, Tom, for that. I want to turn to a question that was put in the Q&A and we wanted to answer verbally. And this is about toxicological and epidemiology studies done on occupational community exposures from recycling of labs in Africa and other LMICs. So I'll hand it over to Chris for that answer.
Thanks. Most of my focus has been on the community health impacts, so I'm less well versed in occupational exposure. Most of the studies to date have been more focused on lead levels in the environment. So most studies you'll find measuring lead concentrations within a few kilometers of smelters with XRF. A few studies have then translated that into what we expect the blood level impact to be using tools like biokinetic modeling, like the IEUBK model or all ages lead model, where if you know the concentration of lead in the soil and you can estimate how much lead people are ingesting that each day through hand to mouth, then you can predict the blood lead level that comes from that. There have been a handful of studies that have directly measured blood lead levels, so comparing what is the concentration of blood in the community that is based 2 kilometers away from the smelter versus a community that's 10 kilometers away from the smelter. And then also similar studies measuring educational outcomes. So how do children who live close compare on test scores for reading age or other educational metrics versus communities further away? But a key challenge there is you have to decide, okay, what is the background level of exposure? Okay, you have someone that's 2 kilometers away that has a blood lead level that's 3 or 5 micrograms per deciliter higher than someone that's 10 kilometers away. But for that person, that community that's 10 kilometers away, how do you know that they're not experiencing impacts from that pollution? What I think is really missing, and the study that I want to see and I'm proposing, is I want to see concentrations of lead in the environment measured at lots of different distances away from smelters. So lead in air, soil, dust, water, and food crops. And then using techniques like isotopic analysis, where you can say, okay, we know the concentration of lead in this environmental medium, but we can actually then, with those techniques, figure out what percentage of the lead is coming from the smelter. And we might also be able to do that with blood as well, where if we find someone that's 10 kilometers away from the smelter, we'll see, can we see this chemical fingerprint of lead pollution from the smelter appearing in their blood? So as far as like, has there been a comprehensive study that will tell you, let's look at the smelter, what is the cumulative health burden in terms of IQ points lost, increased risk of dying from cardiovascular disease, and what fraction of that is coming from the soil or from the air, from the food? That hasn't been done. And I think doing that study will be a really good vehicle to motivate governments to take action when we can actually look at a smelter and say, okay, it's going to cost this much to fix the smelter, but here are the public health gains that we will get from doing that. And we can truly understand the cost benefit analysis of interventions. And I think because at the moment those studies haven't been done, my theory is that we are significantly underestimating the health burden. So we are devaluing sort of the benefits of taking action.
Great, thank you very much, Chris. Someone had their hand up but took it down. If you're still here, please either type your question in chat or raise your hand again. I think we have time for 1 or 2 more questions. We have a couple in the Q&A. If nobody has, okay, you've raised your hand again. Thank you for your patience. I'll unmute you. Oops, I think I did. Go ahead. Oops. You should be able to speak now. Abraham, are you able to go ahead?
Can you hear me?
Yes, we can. Go ahead.
All right. All right. So this is Abraham, MRI, Ghana. Yes. So I've followed keenly the webinar, and in fact, it's quite interesting. I've learned so much, but I have a key question to ask. Please, how can, ULABs strengthen its role, okay, as a strategic hub for, say, applied research, technological innovations and sustainable development? How can ULABs strengthen its hub? Okay.
Thank you.
Strengthen its role, okay, as a strategic hub for applied research, technological innovations, and sustainable development.
Okay. Who wants to take that one? Fred, you unmuted?
I will take it shortly. I think the
We
point
have
is
about
that
5 minutes, so maybe about 1 minute, and then we'll do wrap up.
Yeah, the point is that it is not it is not to discourage ULABs. ULABs will be in Africa for a while. We know a few years ago the talk was, oh, ULABs are the thing of the past. This is not true. Because of the applications being done, it's going to stay with us for a while. There's a lot of investment in the sector. It's still a very valuable commodity. In fact, even in electric vehicles, they are still lead-acid batteries in some of them. So it's going to stay with us for a while. And the point is to keep it. And to really use it as a lever for more sustainable jobs in Africa. It's not about jobs all the time, but jobs that are actually sustainable that can support everyone. Thank you.
Great. Thank you for being quick. We have 2 more in Q&A, actually 3 more in Q&A that I'll try and answer. Actually, they're probably longer than we have. So the first one on social and behavioral change, Sophia, if you reach out to me, I can provide you more information on that, but there is guidance on how to try and affect social and behavioral change. And then the other ones will reach back out to you. Actually, one of them, a comprehensive recycling audit. I think using the SOPs that I put in chat would be one way to do that. And then the contamination risk, that's a longer conversation. So Ariane, maybe we can be in touch. Christopher's typing the answer there. So I think it's time to wrap up with key takeaways. This has been an incredibly rich discussion. Thank you for all of you who have attended and stayed so long, an hour and a half. I'm going to turn it over to Tom to mention a few key takeaways, and then I'll close the session. Go ahead, Tom.
Yeah, thank you. I just had a couple of things coming out of this discussion that I don't think are covered in the tool, but are really, really important. One, from Dr. Atiemo's presentation, I think your story of the change in Ghana, Dr. Atiemo, really emphasizes how policymaking in this area is an iterative, drawn-out experience. And the number of stakeholders that need to be involved. This is not really covered in the tool because the tool is more about the options that are available, but I found it a very helpful reminder of how important these kind of policy dynamics are. And the second thing that has been on our mind a lot, at least at Labry, but that Chris mentioned, is the relationship between ULAB recycling sites and food contamination. So a lot of the research that Chris mentioned, as he said, focused more on kind of airborne lead, and that's been the main basis for estimating burden of ULAB recycling up to now. But this avenue for food contamination seems like a really interesting area for further research that may influence our understanding of how large ULAB recycling's contribution is to lead exposure, and also potentially policy solutions further down the line.
Great. Thanks so much, Tom. And I also want to thank you again, you and Michaela, for leading the design and writing of the tool, and for the reviewers who are part of it. They're in the acknowledgements if you want to know who they are. But I would like to close the webinar by saying, please do look at the tool. We will have the webinar recording available for you. We will have the slides available to you. So please use this as an opportunity to educate yourself. We hope this isn't the last time we get together on this. And certainly, if you have any questions or require any assistance, I've put the PLF Secretariat email into the chat. So please feel free to reach out there. We'll be monitoring that for your questions. And for those of you who we didn't get to your questions, I also will be sending out an email to all the registrants with the link when the slides are available. So with that, thank you so much. We look forward to keeping in touch, and thanks again to the speakers, and have a good rest of your day. Thanks, everyone. Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thanks a lot.